Hello. Today you can see prototype installation of mpguino for my car. This is the open source project made by people on ecomodders.com forum. Its primary use is to gather information in order to drive more efficiently with more mileage per gallon. I'm using the firmware or software developed by tvago, so thank you everybody involved in this project. So here I am using Arduino Nano on a breadboard, obviously, and it is broken out for the 1602 display in parallel mode. I'll be connecting it remotely with the ribbon cable I took from the old computer for parallel ATA hard drive. So this is just to see if everything is working, just alpha version prototype. Additionally, here I have 3 buttons connected directly to digital ports. Installation to the car is really not very difficult. Here goes the fuel injector sensor wire, which is connected to the Arduino digital pin via resistor to limit the current, and there is also a Zener diode to clip off any overshooting voltages. It should be 5 volt signal, so this is 5.1 Zener diode, and here goes the vehicle speed sensor, and it goes to Arduino analog pin. Now this should be connected to always on power, but for the first try I'll just connect it to the accessory power via Arduino USB power port, using the standard cigarette lighter thing. Mr. Thomas Vago made auto restore and auto save feature in his version of the mpguino software. So when you turn on your power, all previous settings will be available. So you don't have to input the settings again, and the counter should not be reset, hopefully, maybe except the real-time clock. So installing this in a car, at least temporary, should not be a problem, but getting the setup right inside the software, getting various parameters will be more difficult. So let's get going, install this thing. I made a very temporary installation of my mpguino. As you can see, it's very DIY or shoddy or botchy. You may call it all this with full right. Here is the display connected with hard drive ribbon cable to the breadboard with everything, with Arduino Nano, buttons for controlling it. It is getting power supply via this accessory adapter or cigarette adapter. Inside that adapter there is voltage regulator, just like this. It is a cheap ass eBay thing which takes down 12 volts and supposedly regulates it to 5 volts and 1 amp. And I connected that accessory socket to the spare fuse connector here, which is 12 volts, and ground to the ground goes to the mounting screw of the fuse box. It's just over there. I cannot see it with the camera now, but it is there. This is fuse number 6. If you have a Honda Civic like this, in 6th generation Honda Civic, it is not used, and it has constant uninterrupted 12 volt in case you need it for a project. Now I got a vehicle speed sensor and injector pulse signal directly from the engine management unit or the engine computer, which is under here. I can post the picture of it. So I just took the connector off and soldered some old leftover feet from some components, through-hole components, to stiffen the wire, and pushed inside the connector on the cable side, and secure it to the cable with some insulating tape. I hope you understand how I did it. It is simple and it works. I used this wire for connecting the sensors. I had it at hand. It is 0.16 square millimeter wire. It's copper wire, very thin. Maybe you should get, it does the job, it's okay. Maybe you should get 0.25 square millimeter section wire, but yeah, this seems to do the job for the sensor. And I also used some double tape, the one that is sticky on both sides, to secure this, although it's not secured very well. So without further ado, let's fire this thing up. So as you may or may not see, it is showing current consumption, liters per hour, since I'm not moving, and yeah, it froze. So the thing is showing engine RPM correctly, and the current consumption is probably correct also, 1.16 liters per hour. It is in the ballpark of correcting. You can see the RPM gets corrupted from time to time. I don't know exactly what is the deal here. I think now, and it goes back to normal by itself without resetting. So I'm not sure what's wrong here. I suspect the power supply is not adequate for this. This AVR microcontroller probably requires a more stable power input. This thing doesn't draw much current, so I don't think it is overloading the voltage regulator, this cheap ass. I don't know what is inside this Chinese thing I showed you before. It's probably the stability problem. Here it goes again. Let me add. Okay, my GPS recognized something I said, voice command, so whatever. So let's see if this thing goes back to normal. Okay, whole display froze. I think now it's dead. Okay, I thought that thing died, glitched, but actually didn't. It still works. I didn't reset it. I just browse through menus up and down, and now it works again. Now it doesn't work again. So I think it is the power supply. I'm not sure, but okay, for the first run it's okay. I take back what I just said. It's not okay. It's getting worse and worse. So there is definitely a problem here. Now there is nothing on the display. So this thing is sending corrupted data, is corrupting data. So it's not, there is some serious problem. But anyway, what I wanted to say, I actually didn't connect the vehicle speed sensor because I didn't have another Zener diode to chop the spikes out of the signal. I don't want to connect it like that directly to Arduino because it is 12-volt signal with lots of noise spikes probably, and today is Independence Day here. Shops are not working, so I cannot just go and buy Zener diode, so it will have to wait for tomorrow, hopefully. Unfortunately, there is something terribly wrong with this thing. Maybe it's just the power supply, maybe the Arduino is fried, maybe the injector pulse signal is causing corruptions. So let's press reset on the Arduino. Okay, now it kind of works for some time, but yeah, I'll tinker with it and see you next time. Thank you for watching. Okay, here we go. And if you like this video, give it a thumbs up. Thank you. Bye.